Jasmine's name is on the board. She never gets in trouble. You're in good company. This is not the naughty list.
Really?
Okay, I also want to remind you all that, thank you, David. Tuesday is the reassessment opportunity. So for those of you that have a quiz grade that you're dissatisfied with, Tuesday is when you fix this. And how do we fix it?
Tutorials one day. Tutorial 9.
Okay, hold on. Don't you sign the quiz. Get your mama to sign the quiz. Mom or dad, not stranger Bob who wanders Anderson Road and pays $1 for his signature. Okay? That's step 1. Step 2. Jose. Tutorials so that you can do the corrections. Yesterday, who stayed? Brianna stayed, and somebody else stayed, and Noemi stayed. We made all the corrections. We answered all the questions. We were so much better. I'm guessing that the other 25 of you are planning to stay Monday. Yeah. That must be what it is. And the quiz is Tuesday. Jose? No, I can't say today. Okay? So we're in like filming mode now?
Yeah, we've been in
calculators out
for a minute.
We've got the problem set out. We're ready to go. 3, 6, 9, 12, 16, 20. Good news is next week when we're on Green Week, you guys are my first calculus class of the day, so I'm not filming you all. I'm filming the other class. Part of it is so that I look smarter on camera. Okay.
It doesn't really count when you say that and we're on camera.
That's okay. I'm off here. They won't know. All right. So yesterday we talked about asymptotes. We talked a lot about asymptotes. So lots of examples, lots of parent functions. Anthony wasn't here yesterday. Edgar wasn't here yesterday. I don't want to make them feel too badly right now, but I want an example of a parent function that is continuous and has at least one horizontal asymptote. I want hands. A continuous parent function with at least one horizontal asymptote. 21 people in the room, I see no hands. So sad. I see Adriana, I see Rambir, I see Jasmine. Adriana, give me an example.
Y is equal to e to the power of x.
E to the power of x is an example of a continuous parent function with a horizontal asymptote. Marvin.
Y equals arctangent.
Ooh. Now you're going big time. Y equals arctangent of x. Is it continuous?
Yeah.
Does it have an asymptote?
Yeah, it sure does.
Even better than that, it has 2. It is the one parent function that we know of that does that. Other examples of continuous parent functions, go for it.
Y to the negative ex, or e to the negative x.
Y equals e to the negative x power, okay? All right, new question. I want a continuous parent function with a vertical asymptote. Talk to somebody near you, don't talk to me. Continuous parent function with a vertical asymptote.
Continuous. Oh, that's impossible. Vertical asymptote. It's a trick question.
Continuous parent function with a vertical asymptote. No, it is not a trick question, people in front.
Vertical asymptote.
Check out those parent functions in front of you. You got them.
How can it be continuous?
Continuous parent function with a vertical
Couldn't it
asymptote.
just...
I can think of one. It seems like no one else can think of one.
This is vertical, right?
Giselle, what's it going to be?
Natural log of x.
One more time.
Natural log of x.
The natural log of x is continuous. I can draw that without picking my pencil off the paper, and it has a vertical asymptote. I want a parent function that has a vertical asymptote but no horizontal asymptotes. I want vertical asymptote or asymptotes if you would like, but no horizontal.
Yeah.
I know it's the end of the day on a Friday, but a lot more folks. You've got the parent functions in front of you. Vertical asymptotes, no horizontal. Martyr. I keep hearing, I don't hear the end of it though. I hear tangent, but... Oh, tangent of x, thank you very much. Tangent of x is an example. Kimberly, do you have another example? Y equals cotangent of x. Thank you very much. Rambir?
The natural log of x.
The natural log of x has a vertical asymptote but no horizontal. These are all great examples. Fabulous. So let's go back, shall we? Let's go back in time. Hop into the TARDIS with me.
The what? Oh, I know.
Okay, it's a Doctor Who thing. Here's what I want to do. I want to spend some time, I want to go back to this not parent function. For Anthony and Edgar, you guys definitely want to be game on here. Yesterday, at the end of class, we were going fast. We talked about this function. We talked about finding vertical asymptotes. Is that where we were? Okay.
But the holes, that's where the...
Right. How do we find vertical asymptotes? Where do we start the conversation? Where do we start the conversation, Jose?
Denominator equal to 0.
One more time.
Set denominator equal to 0.
We set the denominator equal to 0. And I know we did this yesterday, so you've got this in your notes, and I'm going to go fast. And if you solve this equation, you get x equals -2 or x equals 2.
Yes.
And I called these the vertical asymptotes?
No.
I called these the candidates.
Ooh.
These are the candidates. They might be vertical asymptotes. How do we actually figure out if they are vertical asymptotes? David, what do? We've got candidates. These might be vertical asymptotes. Now what?
Oh, you might plug them in.
No, you will plug them in. But what do you mean plug them in?
Plug them into X.
You're going to plug them in? Is that what we're doing? Jasmine, what do we do?
Set them as limits.
You're going to use them as your limits. You're going to say, what is the limit as x approaches 2 of 5x minus 10 over x squared minus 4? And you're going to find the limit as x approaches -2 of 5x minus 10 over x squared minus 4. In this case, if you try the plug-in, you got 0 over 0. But we did a little like factor cancel action, and I think we finally got 5 over 4. Over here, when you first do the plug-in, you get -20 over 0. And what we conclude is that this must be one of the infinities, either positive or negative infinity. I know I'm going fast, but we talked about this yesterday.
Yes.
Is everybody okay? Which one's the vertical asymptote? Which one? X equals 2? X equals -2?
Yeah.
Abraham, which one? How do you know that? One more time? Because the limit is one of the infinities. Now here's the thing. You guys are going to get some homework this weekend, and you're going to think this is the answer. This isn't the answer. The answer is, where is the vertical asymptote?
-2.
The vertical asymptote is at x equals -2. The answer over here, your conclusion, you're getting, you can turn that off. It's not 5 over 4, what we know, I'm sorry. We get 5 over 4, which is not one of the infinities. So what we say is we have a hole in the graph at the point 2 comma 5 over 4. That's where we were yesterday. This is where we ended.
Yes.
Pretty good? Now I want to find horizontal asymptotes. To find the horizontal asymptote, we're going to take the limit as x approaches infinity of 5x minus 10 over x squared minus 4. And I'm pretty sure we didn't get to this part yesterday. I want you to have a quick strategy conversation with folks near you. What would you do?
Hold on, I got these notes, cuz.
36, 9.
At all.
Hey,
I see 20 people. Not 21 though. Who's missing?
21.
Jennifer
F.
Jennifer Flores.
Not you.
I remember writing set denominator equal to 0.
Set all of it.
But it was somewhere her. Is it? Is that what you do?
That's what I think.
Shake, 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 shake it. Dang, I forgot the camera's on.
I know I keep forgetting it.
I can't be sleeping on
Not
it.
hearing nearly enough conversations about how you're going to evaluate this asymptote.
And where's the
So,
notes at, cuz?
that's a 5, right? 5x. You can, what you call it, factor. Oh, it's going to infinity, huh?
Okay. All right, when I say calculus, you say ready. Calculus. Ready. Calculus. Ready. All
I don't
right.
think that was really.
How many of you all tried plugging in? Nobody? Why not?
It's infinity.
Why, I'm curious. Why did nobody try plugging it in? Because it's infinity. And what do we know about the infinities?
It's infinity.
We don't ever plug in infinity. But what if you had humor me for a second. What if you had?
Infinity minus 10 is infinity.
Infinity minus 10 is
Infinity.
Infinity squared minus 4?
Infinity.
Infinity. You know what infinity over infinity is?
Infinity.
No.
It's 1.
No.
0.
You don't know. You don't know.
Undefined.
Not undefined. One more time. Great guess.
It's like 0 over
This-
0.
It's, one more time.
0.
It's like 0
Oh, I was
over
right.
0.
Dubs. That's dubs.
Then make sure you get this in your notes. This is indeterminate form. Stay with me. This is indeterminate form number 2.
Ooh.
Indeterminate. So here we're like, but what was indeterminate form number 1?
The one we've been doing.
0. Indeterminate form number 2, infinity over infinity. For indeterminate forms 3 through 7, take calculus 2.
Chill.
Okay.
What?
So we've got an indeterminate form, so that's a sign to like, let's go do some more algebra. I heard a lot of people that said, I'm going to factor and cancel. Those cancel out. Look at me writing that annoying little brother every single step of the way. 5 divided by x plus 2. Until I get to the plug-in, I have to keep writing it. Hold on, Jose. We're okay with the factoring and the cancel? I bet now this is easy. X is approaching infinity. What happens in the denominator? Infinity.
5 over infinity.
5 over infinity
0.
is 0. Do not stop here. Don't tell me this is your answer. It's not the answer. Because the question I'm asking is, where's the horizontal asymptote? Where's the horizontal asymptote?
You have to
Where's that horizontal asymptote?
solve.
Adriana, what do you think?
Is it at 1 equals 0?
Right, the conclusion is that you have a horizontal asymptote at y equals 0. Yeah.
So to find horizontal asymptote, you just solve the limit.
Because when I say horizontal asymptotes, what you really hear in your head is,
What's the
we did this yesterday, horizontal asymptotes,
And behaviors.
And
it's
behavior.
the end behavior. Right? So what this is telling me is that as I take the limit as x approaches
True.
infinity, my y values get closer to 0. They're heading out towards infinity. Is the video okay? Here's what I want you to do. Martyr, you're going to go back to your spot. Okay? I want you guys to graph this function on your calculator and get me the evidence that I'm not lying to you. Get me the evidence that I am not lying to the Maverick Nation and the North Forest Legends and the East End Explorers and the Southeast Wizards. I wouldn't want to lie to like all of you.
Oh, that's the south.
No.
Okay. Graph this on the calculator. Get me the evidence that I'm not lying to you.
Hey, Mr. D, are these videos going to be available online so that in case we want to go over these, we can watch it too?
I'm going to work on that, yes. I think that is a great idea.
Oh.
And boom. Okay, and Martyr, you're going to get really good at this. Somewhere in the bottom, there's like a little red, like swirly arrow. Do you see it?
Why is this in Mark,
You're gonna get really good.
Angelina. Teresa.
Who's Alondra?
My name is there.
Jenny or Daniel.
Okay, I want you to graph. I want everybody to graph 5x minus 10 over x squared minus 4.
I'm just waiting until how long this will be.
Okay.
To
Graph 5x minus 10 over x squared minus 4.
I'm just trying to see.
I need to update.
Martyr, can you do Control T to get this out of here?
Oh, that's a bit.
Control and T. Oh, you've got to move the mouse so you're over here in the table. Now Control T.
Oh, chill.
Control and T. Or maybe it's on the graph. Try it on the graph. Over here on the graph.
You have to click.
There you go. Okay. Looking at the graph, do we have evidence of asymptotes? Let me ask that question again.
Yes.
You're looking at the graph. Is there evidence of asymptotes?
Yes.
Horizontal asymptotes, we're talking about end behavior. If you see that as the graph is heading towards infinity, right, if you're seeing that it's getting closer to some value, you have a horizontal asymptote. If you head out this way, wait, oh, you haven't changed the function yet. That's the problem. Martier,
Denominator.
you need to graph 5x minus 10 over x squared minus 4. Okay. Yeah, hit tab and type 5x minus 10 over x squared minus 4. We're going to figure it out. It's all going to be good. Okay. Everybody still with me?
Yes.
I know we're having some technical difficulties here. It's going to be okay. Okay, 5x minus 10 over x squared minus 4. Okay. We hit enter. Good. This is the graph that everybody has in their calculator?
Yeah.
Okay. So here's the thing. I can see that as I take the limit as x approaches infinity, I see that the graph is flattening out, but I can't see what it's getting closer to. What do we do?
Hey,
What do you do? Robbie or Freeze? What would you do? What would you do? How would you find the limit as x approaches infinity on the calculator? Nobody? Naomi, what would you do?
Make a table and you plug in the.
One more time. I heard you say we're going to make a table, and then we're going to plug in the values.
Oh, yeah.
So let's do that. Now do Control T. So Control T. And do you remember what you do next? It's menu, table, edit table settings, switch to ask, and I want you to plug in values that get you close to infinity. There's no infinity button. So big numbers.
100.
10, 100, 1,000. Get them in there.
10, 100.
How you do that?
Yeah, don't go too crazy. If you get too big too fast, you're going to get an overflow error.
10,000.
Okay? And remember, I'm looking for stabilization of the first 3 decimal places. And Abraham, I know you see it. What's the limit going to be? 0. Does that match what we already knew?
Yeah.
That is absolutely what we already knew. We have a horizontal asymptote
No,
at y equals 0. Now let's go check the other one. Go check the other one. So you're going to do limit as x approaches negative infinity.
Infinity equals 0.
So like negative 10, negative 100, negative 1,000. David, have you already like figured all these out? You already tried them all? Okay.
I got negative.
We should be getting 0
Not the
again.
same thing.
Yeah, I didn't.
Okay. And Mariah, I love the way you said it. You're like, it's the same thing. In the world of, make sure you hear this, a polynomial over polynomial, they will always be the same. When you just have a rational function, when it's a polynomial over a polynomial, the horizontal asymptote over here, the horizontal asymptote over here are always the same. So good news. Don't do both. Just do one. Everybody okay?
Polynomial just no.
Polynomials have the form, it's like x to the 4th plus x cubed minus x squared plus 2. All the exponents are whole numbers. There's no square roots, no exponentials, no fractions. Here's what I want you to do. I want you guys to take a couple minutes. If you look at example number 1 on the top of page 4, that is a good function. I want you to use your knowledge of limits first to find the horizontal asymptotes, vertical asymptotes, and discontinuities. And then we'll talk some calculator stuff and we'll go from there. I'm going to give you 5 minutes. Example 1, top of page 4, and mark here. If you want to maybe join the friends over here.
Hey, don't be laughing at my cuz like that. I'll beat you up.
If I keep trading people out, they're never
just kidding around.
You're going to get really
So
good.
clutch. You can factor out an X at the bottom.
Yeah, you can.
Oh!
Fire!
Get him. Get him.
Okay.
What are we searching for though? Horizontal asymptotes?
Okay.
Alright, cool.
Vertical asymptotes from
Girl, don't be. Okay.
3x squared over 2x
Yeah. Okay, so the problem
I still can't factor nothing.
you see just a little hint over here. It says 5, and then there's a negative sign. That's scientific notation.
Okay, now what?
Like 5 times 10 to some negative exponent.
What's the next?
Which means
Okay, for horizontal asymptotes. No. First we saw for vertical.
so
Denominators? Is that what we mean? I don't have my notes.
I don't have my knowledge.
I feel like we should have asked him. Calculus students last year. Track the notes.
You had 2 systems that took calculus.
Mr. Ness said.
okay, and for you guys, now that we're going to get really good at this, when it's like student practice time, we're going to like turn the camera so this becomes like the other person at the table.
Turn it on them.
Turn it on you all so that like the conversations you're having are here. This is not to get anybody in trouble, okay? But for 5 minutes of them just watching the board doesn't do anybody any good. But if we can just turn the camera.
Can you get my good side?
Okay. It's totally gonna be okay.
I'm serious.
Okay, this may be too big of a deal. All
My
right,
SoundCloud.
keep talking. We're not clowning around.
Alright. We factor out the
So you guys
two.
factored it out?
Love it. I'm seeing most folks are attacking those vertical asymptotes first. They're setting the denominator equal to 0.
Set that
They're
denominator.
solving.
Ooh, after you factored it out,
That's
set it to
great,
0.
but that's not the answer.
Oh wait, so horizontal is the numerator then?
Horizontal. What's that?
Horizontal asymptote.
Horizontal is the same is the whole equation.
Oh, the whole equation.
Cuz.
Yeah, I'm confused myself.
Just look at this vertical asymptote. Look what you did here.
We didn't even finish that one.
Okay. So it looks to me like everyone's figured out x equals 0 and x equals 3 are the
Candidates.
candidates. Jose, how are you going to decide if they're actually your asymptotes?
Bring that here, boy.
I'm sorry, you're going to what? You're going to, it involves limits. Okay, you're going to take the limit as x approaches each candidate. No shame, we're going to get better at this. Okay, so what I expect is everybody's like in this limit process right now.
I got 0 and 3. Yeah.
Okay, I'm not going to ruin any more fun, but you've identified your candidates, taken the limit as x approaches 0, taking the limit as x approaches 3. We're evaluating the limits, and that's going to tell you everything.
See, we were doing this. Well, I don't know why we stopped halfway. Are you guys doing it?
It became lost over.
So when we plug in 0,
Bro,
I
I
got
gotta
0
turn it
and
back
0.
around.
That's your candidates.
Come on, cuz. What do you do?
It's all over your face.
How's it? Is it zoomed in?
It's just on YouTube.
Chill out.
Nope, you don't need calculator. I want you to evaluate those
Alright,
limits
so
using
then,
your limit.
the 0, you're gonna get 0 to
So
0.
Jonathan,
and
if
then
I
1 in.
tried evaluating the limit as x approaches 0 by plugging in, are you okay that we're going to get 0 over 0? So what would you do? Okay, so what I want to see in your paper then is you're taking the limit as x approaches 0, and we are, hang on. If you're making good progress, keep going. Don't wait for me.
So he factored it in.
Right. I want to take the limit as x approaches 0, but they gave me 0 over 0. That's not an answer. So I'm going to factor. Factoring is good because now I can see that this x and that x are going to cancel out. Robbie, you can just leave the camera.
I didn't touch it.
Should be 3x over 2 times x minus 3. Try plugging in now if you can.
0 over 0.
And if we get 0 over 0, that's a bad thing. I get 0 over, what is that, 2 times negative 3? Which is 0. So what does that mean?
It approaches 0.
It means that as x approaches 0, the y value approaches 0. Does that mean vertical asymptote?
Sure it is.
Okay, I feel like I've lost everybody.
You have.
Okay, so let's back up on this. So whatever you're doing, stop a little bit. Y, did we set the denominator equal to 0?
Find the x
To
value.
find the candidates. To find the candidates for the vertical asymptotes. So to determine if it actually is a vertical asymptote, you evaluate the limit as you get closer to your candidate. You want to know what happens as x gets closer to 0, what's going on. As limit as x approaches 3, what's going on. The work that we just did said that as my x value gets closer and closer to 0, my y value is getting closer and closer to 0. Is that what vertical asymptotes do? Think about any parent function you've ever seen. If I say vertical asymptote, what does that graph do?
It won't touch that part.
It
Infinity.
heads up towards positive infinity or
Negative.
goes down towards negative infinity. Do the y values get closer to 0?
Nope.
No. So what is this?
A hole.
It's a hole. It's not a vertical asymptote. The conclusion is that you have a hole at x equals 0. Let's go through and find the limit as x approaches 3.
So limit.
If I find the limit as x approaches 3, maybe my first move is the plug-in step again, right? Let x equal 3. 3 squared is 9 times 3, that's 27. 3 squared is 9 times 2, I've got 18, minus 18, 0. Is that the indeterminate form?
Nope.
No. Top is getting closer to 27. The bottom is getting closer to 0. What's happening? Numerator gets closer to 27. The bottom gets smaller.
Infinity.
If you're not sure, try it on your calculator. Take 27 and divide it by numbers that are getting smaller and smaller and smaller.
Infinity.
What happens?
Infinity.
You're heading off to one of the infinities. It's either positive or negative infinity, depending on the side we're talking about. So when you see this as your answer, your conclusion,
It is a vertical asymptote.
right? This is how vertical asymptotes behave. So I would say vertical asymptote at x equals 3. We're not done. Stay with me. We've handled vertical asymptote conversation. We're almost done. The last piece, I need to go for those horizontal asymptotes. So let's go for the horizontal asymptotes.
All right. So.
Daisy, do you remember how we find the horizontal asymptotes?
We were finding, no,
The one that's closer to
the vertical asymptotes are the one we're going to use for the...
Right, we're going to say what's that limit as x approaches infinity, and the problem here was what, 3x squared over 2x squared minus 6x? Right, this is how we find horizontal asymptotes. If we tried plugging in infinity, which makes no sense, I hope everybody would tell me you can tell me what happens in the numerator. X is approaching infinity. X is approaching infinity. We're squaring something that's approaching infinity. That's infinity times 3. I think that's still infinity. In the denominator, 2 times infinity squared. Infinity. I'm getting infinity over infinity again. Not an answer. Infinity over infinity is that other indeterminate form. I want to show you guys a new way to evaluate this. We're going to find the limit as x approaches infinity. I'm going to multiply by 1 over x squared over 1 over x squared. I bet nobody saw that coming. convince your neighbor that it's legal.
1/2
Why is this legal? Don't tell me, tell your neighbor. Why is it legal for me to multiply by 1 over x squared over 1 over x squared?
He's a
Close
math
to
teacher,
zero.
so he makes it legal.
Isn't it because
Not
I don't
because
know
I have a
why.
master's degree.
But
it's
when you
legal. There's a reason that sixth graders know.
It's closer to 0.
Why is it legal to multiply by 1 over x squared over 1 over x squared, Nora? What am I really doing here? 1 over x squared over 1 over x squared. What is this really? Don't go big brain on me. Keep it simple. 1 over x squared divided by 1 over x squared is... Which is really what? Why is it legal then to multiply by 1 over x squared over 1 over x squared? Because it is 1. It is fancy 1. Just like when you multiply by the conjugate, right? It's a fancy 1. This is 1. Now, I didn't ask the question, why am I doing that? I just want to know, is this legal? Yes, this is legal. Okay, check it out. Let's look at why it's actually better though. Think algebra 2 skills. I want to multiply the numerator by 1 over x squared. 3x squared times 1 over x squared? 3. In the denominator, 2x squared times 1 over x squared? 2. Minus 6x times 1 over x squared?
6 over x.
It's 6x over x squared, which I can make 6 over x. Sure.
What the heck?
I multiplied by a fancy 1, a convenient fancy 1 to get me some progress here. Take the limit as x approaches infinity.
0.
X approaches infinity, what happens over here? Gets small, gets close to 0. So the denominator, I have 2 minus 0, which is 2. In the numerator, I have 3. The conclusion is that I have a horizontal asymptote at y equals 3 over 2. And I bet, if you think back to conversations you had with Mr. S, some of you might have known in the very beginning that it was 3 over 2. Did anybody see it right in the beginning? Marvin saw it right in the beginning? Mariah is maybe starting to make some connections. The bells and whistles are going off. Look at the problem again with fresh eyes. Where's that 3 over 2 coming from? Where's that 3 over 2 coming from?
That's what I'm saying.
Right there.
Mariah, where did you see it?
Isn't it because it's not from Mr. S? I YouTube this, but I saw
That's fine.
I saw something where like
Come on up.
that if
Come on down.
these two are the same, then like you can automatically just use that.
When the degrees
Yeah, the degrees are the same.
are the same, degree 2 in the numerator, degree 2 in the denominator, what do?
No,
It's not that you divide everything by that. Think about that 3 over 2.
You just use those two numbers that are
The 2 numbers, the fancy word for that, those are the leading coefficients.
Yeah, those.
You take the ratio of the leading coefficients and you get 3 over 2. That's your horizontal asymptote.
You always know it's a horizontal asymptote if the degrees match in the top and bottom?
If the degrees match in the top and the bottom, and I'm asking you to take the limit as x approaches infinity, then you know it's going to be the ratio of the coefficients. Real quick, I want you guys to graph this on your calculator. Make sure that I did not just lie to you. Hey, Marcia, let's get back there. Get me that graph. This is what you guys are doing this weekend.
No.
The thing I cannot give you where it's here is my log. So let's get that new function graphed on there. Yes, sir. The third indeterminate form.
3x squared.
Bruh, chill.
For real, Edgar? That was an excellent question.
I need to take a picture of that sign.
Okay. Get this graphed on your calculator and let's get a sketch on the paper. We're going to have just enough time to do what I want to do. Yes, sir? Yes. Except I wanted you to like... Okay. Look at that graph. Is this graph matching all the things we just talked about?
Let's see. Yeah.
I hope so. Otherwise, I've been making up calculus and trying to sell it to you. Do we see evidence of a horizontal asymptote? Right? At horizontal asymptote and behavior, is this graph getting closer to some y value? Sure. Now here's the thing, and you're going to run into this problem tonight on the homework. You might say, all right, coach, I see that the graph is flattening out. I see it's getting closer to something, but I don't know what it's getting closer to. But I want you to find exactly what it's getting closer to. What do we do?
Table.
I need to get you to shh, just a little bit. If I want you to figure out what's that horizontal asymptote, I want to know what's that limit as x approaches infinity. Martyr, I think you want to listen to Rambeer here. I want you to find the limit as x approaches infinity on the calculator. So go build that table of values for me. Uh-oh. Yeah, just Control T, you got it. I want to make sure you're getting to practice with these skills, Jonathan. Everybody else. Okay. And now plug in big numbers. 10, 100, 1,000, million.
It's 1.5.
And hopefully no surprise what's happening to those y values. Right, we're getting closer to 1.5. That 1.5, you guys all know, is 3/2. So you have a horizontal asymptote at y equals 3/2. Now I've got to check this side as well. Martyr, I want to check this side. We're going to take the limit as x approaches negative infinity of f of x. So negative 10, negative 100, negative 1,000. Plug them in.
Is 1.5.
And it should be 1.5 again. All right. Nice. We see a vertical asymptote here. Now, the vertical asymptote, you're also going to run into some problems this weekend because you're going to be like, I know there's a vertical asymptote, but I don't know where it is.
Where?
Where did we find the vertical asymptote? For this problem, where's the vertical asymptote? Adriana, where was the vertical asymptote? At x equals 3, we had the vertical asymptote. We knew that by doing our limit stuff. Let's do this on the calculator. I want to know what's the limit as x approaches 3. Martyr, I need you to build me a table of values that's going to answer the question. You guys on your calculator, build this. What's the limit as x approaches 3? It shouldn't be a surprise. Get close to 3. So Martyr, close to 3. What is that going to look like? Yeah, like 2.99. Plug, or 2.9. Great. Negative 43.5. 2.999. Possibly too many nines, but we'll see. If you're getting closer and closer and closer to 3, what's happening? You guys have this on your calculator. What's happening? We should be getting closer to negative infinity, but you have to be careful. You're getting closer to negative infinity if you're approaching 3
From the left.
from the left. If you approach 3 from the right, and I want to make sure we're getting this. If I approach 3 from the right, get me closer to 3 from the right.
Dang it.
Right of 3 means now, yeah, you're bigger than 3. You want to delete that stuff out. So like 3.1. Okay, these y values should not be a surprise. All right, we're getting closer to
Infinity.
Infinity.
everybody mostly okay.
That's okay.
All right, so now it's time to like push you guys. Why don't we try example number 3?
Jesus.
Martyr, for now, why don't you join friends over here? Example number 2, my apologies. Example 2, I want you to try this. I'm going to give you 4 minutes. with your calculator, find me those limits.
Where is example? You. Thank you.
Thank you.
Where's the third?
Which example, 3 or 2? Is it 3, Mariah?
You said three.
I thought you said 3.
So example 2?
Example 2.
Says the math.
Okay, I want you to do this using all your calculator powers.
Yes.
Go for it. I believe in you,
I
guys.
don't know how to use that.
Add to class.
I'll try it. I'm gonna pick challenge. Are you?
Hello.
I already messed up.
Walla Washington. I'm gonna find
Yeah,
a
B.
Whitman on your
Do
own.
what?
Did you get that?
And then you do this.
You get this
I didn't get to that now.
Oh.
You get the D. Yeah.
As in Detroit, chill out.
Here you go, buddy. Here's your equation.
Thank you.
Chill.
It's equally on all of us. Can you hear us testing?
Better have a teacher. Back on the teacher.
So it's just like a substitute. Play the video.
I did. So then 0.
Control it. Control it.
Oh.
Yes.
Oh,
Really good assistant. Really. That's
Yours
not bad.
is 0.
who did that? How do you? Blasphemous.
Okay, so
And then you press what? Enter.
Is that what you got?
horizontal.
Is that what you got?
I didn't get that.
No way. So see if who plugged the equation in wrong. No, she plugged it in.
I just have to delete my thing. I don't know how to get off the table. How do you get off the table?
CTRLT.
How do you get off
Do the mouse. Scroll to the side. Do the mouse. Scroll. Do the mouse. I don't know how to get the mouse.
It's not working. It's not working.
Good. Alright.
How do you get the table?
Look, it's gone.
No, it's not. It's
Hey,
I can see
I don't
it.
know negative. Oh, for real? Little child.
Oh, I didn't do the parentheses.
It's got a huge scratch right there.
Well, I just got the house over.
Don't you already have like 3 of them?
Alright. I'm gonna bring your calculator every single day. Hey, I think that calculator is heavy. Take it out.
Round 1. That's what you need to do.
You are asleep.
Okay, let's turn this back around. Let me give that back to you for a second. Alright. Okay.
Oh, yeah, you're right.
What did you say?
What?
Alright, I am not exactly sure what's going on with my calculator. Can I see your calculator for a second? Okay. On Jasmine's calculator,
That says wrong beer.
this is not going to look exactly the way I want it to, but for some reason it refuses to graph the function. Just give me a quick thumbs up if that matches what you have in your calculator. That.
Here, you can take your calculator back.
Okay. Do we have evidence of horizontal
Okay,
asymptotes?
thank you.
Yes. No.
David. Hi. Evidence of horizontal asymptotes. I'm talking about what's happening at the ends. As I'm approaching positive infinity, is the graph getting closer to some value? I think so. I don't know exactly what it is. That's not the question. It's just, is there evidence? Sure. And is there evidence over here that I'm getting closer to some particular value? Sure. I also think that we've got some evidence of vertical asymptote behavior. I've got a vertical asymptote somewhere. We've got just enough time. I want to go through, this is like what you're doing this weekend. I realize it is the end of the day on Friday. I really we're just going to keep on going. Okay, so the function is 5 over e to the x minus 1.
Yes.
Vertical asymptote. Let's get some hands on this. Where did you start? What did you do first? There's 20 people in the room. 20 people in the room. Jonathan, where did you start this process? You set the denominator equal to 0. Okay, now we're back to like algebra 2 stuff, right? Solve the equation. How are you going to solve this equation?
You subtract. You add 1.
Okay, we're going to add 1 to each side, yeah, and?
And then you get e to the power of x equals 1, then you can do the natural log to bring the x down.
Good. I'm going to take the natural log on both sides because I have natural log of something raised to a power. I can bring the power down in front. And x times the natural log of e is equal to natural log of 1. Maybe you know what the natural log of e is. You should. If not, check it up there. It's up there. Check it in the handout that I gave you. Natural log of e is
1.
1.
Yeah.
Natural log of 1, 0. Don't tell me this is a vertical asymptote.
That's a whole.
Why not? Why? There's got to be more than this. Why not? Why are you not going to tell me vertical asymptote? Marvin, why not?
It's only a candidate.
It's a candidate. In order for me to figure out if it's actually a vertical asymptote, I'm going to take the limit as x approaches 0 of 5 over e to the x minus 1. X gets close to 0. If x gets close to 0, e to the x. This is getting close to 1 minus 1. Close to 1 minus 1 is close to 0. 5 divided by close to 0?
And then
It's either positive infinity or negative infinity. Look at your graph. Is that what's happening?
Yeah.
Right. At x equals 0, if I get closer and closer to 0 this way, limit as x approaches 0 from the left is negative infinity. Limit as x approaches 0 from the right is positive infinity. That's the evidence that I needed to say, aha, I've got a vertical asymptote at x equals 0. The calculus, the graph, they match. Jasmine, you okay? Got my vertical asymptote. Not done. I need my horizontal asymptote. Where do those come from? David, how do we find horizontal asymptote?
By taking the candidates and then using them as limits for.
No, hold on. That's what you do for the vertical asymptotes. Ed, you're telling me about horizontal asymptotes.
You're looking at x approaches infinity.
Okay, I want the limit as x approaches infinity of 5 over e to the x minus 1. Have a conversation with somebody near you. What's that limit? Don't tell me, tell them.
what'd y'all do?
Yeah. Where do you get infinity? Where do you get infinity?
Because we're looking for the horizontal asymptotes. That's the end behavior. Okay? Conversations need to sound something like, hey, x is approaching infinity. What's happening to this part? Right? If x is approaching infinity, this gets closer to infinity. I know I'm not writing it because some of it is like starting to happen in the head now. X is approaching infinity. This part gets closer to infinity. Minus 1? Still infinity. 5 divided by getting close to infinity?
0.
Is
Getting close.
0. My conclusion, what I want to see is the final answer, is that my horizontal asymptote is at y equals 0. And look at the graph. That's exactly what's happening over there. The limit as x approaches infinity is 0. I do have a horizontal asymptote at y equals 0. Mistake I want you to avoid, though. There are 2 horizontal asymptotes. Go get the other one for me. Okay.
Oh, negative infinity.
Go get the other one.
Yeah.
Can you explain again how you got to The horizontal asymptote is
I'll do that
0.
with this one. Okay.
Okay.
I've got to find the limit as x approaches negative infinity. Horizontal asymptotes and behavior. As x approaches negative infinity, what is the graph of e to the x cubed?
Okay.
The graph of e to the x gets closer to 0. E to the x minus 1 gets closer to negative 1. So your final answer, 5 over e to the x minus 1 gets closer to negative 5. How many guys honestly came up with negative 5?
Okay.
Either, here's what's happening. Either you're doing it by writing it out, or I'm curious, how many of you are kind of getting to the point where it's just happening in your head now? Like you're kind of thinking about it this way? Okay, so, right? I would hope you'd say x is approaching negative infinity. What happens over here? Almost 0, getting small. Really small minus 1 is negative 1. 5 divided by negative 1, negative 5. What does that mean? That means horizontal asymptote at y equals negative 5. And that is exactly what happened here. Okay? Asymptotes are some big brain stuff. I know I'm pushing you guys a lot right now, but this is where we are. Like the limit stuff, we did it so that we could get here. Give me a minute. Homework this weekend. If you guys look, I think it's the top of page 5, 6.
Yes, 6.
Okay, I want to make sure the instructions are clear here. You are doing round 1. There's a little box at the top that says round 1. Or, oh, fine, be that way. I'll be that picky when I grade your homework.
That's
That's fine. So what does it say?
Round 1.
It says round 1, doesn't it?
Round 1.
It says round 1, yeah, okay.
Round 1.
Anyway, round 1 is all, it's all calculator active.
Edgar.
Right, I want you to graph these on your calculator. I want you to build those tables. I want you to get good with the calculator skills. On Monday, we'll talk about the next part of this. Before you guys leave, there was a problem set that was due today that you took out earlier. And my paper picker-upper, who now is also my camera woman, we've got to parcel out these jobs. I don't want you having both of them. I will see you later. And Adriana, can you be the new paper picker-upper?
Okay.
Let's have her so you can do the camera. Thank you, Adriana. And you guys are
USC film
meat and green? Meat and green. Who's the green folder?
Only round 1, right?
Kind of.
Only round 1 this weekend. Is the camera off?
No.
Let's go.